We already know that killer whales rule the oceans because they are strong and work together very well. But their intelligence goes even further than we once thought. Orcas can learn, think through problems, and talk to each other in their own special way. In the wild, scientists have seen orcas bring food straight to humans, then stop and wait to see what the person will do. When they act like this, it makes you wonder, could this whale have its own human researchers? Orcas sent out just to study us, trying to figure out what this strange whale on land standing at the edge of a boat really is. To understand why one of the ocean's fiercest hunters acts this way, we first need to look inside the body part that makes it all possible, the orca's brain. This is a body part that still puzzles scientists today. A female orca can live for 80 years, sometimes even 90. That's about twice as long as most other sea mammals live, and it creates an unusual way of living together. In one pod, 4 generations grandmother, mother, daughter, and baby can stay together, swimming side by side for decades. The basic family group of orcas is called a matriline, led by the oldest female, along with her children and grandchildren. Unlike most other animals, grown male orcas don't leave to find their own space. Instead, they stay with their mothers for their whole lives. Several related matrilines join together to form a pod. Several pods that share the same area, habits, and traditions make up a clan. This steady, layered way of living has lasted for many generations. And that steadiness is what makes something even more important possible, passing knowledge from one generation to the next. Most of what an orca knows isn't built into its genes. It is taught. Scientists have often seen grown orcas, especially mothers, change the way they hunt when young calves are watching. Instead of killing prey right away, they take extra time and effort to herd it first, then let it go so the calf can practice finishing the hunt itself. This has been seen in many different orca groups, which convinces scientists that it's done on purpose, real teaching, not just chance. In animal behavior science, this is called social learning skills by watching or interacting with others, instead of just guessing or being born knowing it. What makes social learning different from a simple habit is that it can spread. A habit only belongs to one animal. But something learned by watching others can spread through a whole group, last for generations, and slowly change over time. When a group of behaviors spreads this way, staying the same within one group, being different between groups, and having nothing to do with genes, scientists call it culture. They mean this in the real scientific sense, not just as a way of speaking. One clear example is the different types of orcas, called ecotypes. Around the world, orcas are split into different groups based on how they live. Some, called residents, only hunt fish. Others, called transients, or Big's killer whales, mostly hunt seals and other sea mammals. Still others have learned how to hunt sharks or deep-sea squid. These groups are almost the same in genes and body shape, but their hunting styles, sounds, and even how they organize socially can be very different. In other words, their bodies are nearly the same, but their behavior is not. The gap is filled by knowledge passed down from parent to child through teaching and watching, slowly building into a special set of traditions for each group, something scientists call ecological culture. Much of what we know about this comes from years of study by John Ford, Michael Bigg, and other researchers in the waters of British Columbia. By recognizing each orca by its fin shape and scars over many years, they showed that the long-lasting family structure works like a living library of knowledge, letting information build up instead of disappearing when one orca dies. But if behavior can be learned and knowledge can build up over generations, what about the tool that makes all of this possible? How do orcas share so much information with each other? If the mother-led family structure is the foundation that keeps knowledge safe, then the orca's sound system, its calls, is what keeps that culture alive. Orcas use 3 main kinds of sounds: whistles, which are long sounds that change pitch; echolocation clicks, short bursts of sound that bounce off objects so the orca can see in the dark; and, most often, pulsed calls, fast bursts of sound that people usually hear as sharp squeaks or high screeches. Each group of orcas has its own set of pulsed calls, called a repertoire. The way these calls are put together creates a dialect that belongs only to that group. Here's an important point. An orca's dialect isn't something it's born knowing. A baby orca doesn't automatically know its mother's dialect. Instead, it learns it by growing up in its pod, listening to and copying the sounds of the orcas around it. This is a kind of learning passed from parent to child, much like how hunting skills are passed down. Because dialects are learned, not built into their genes, they slowly change over time, very much like regional accents change in human communities. This connects to the idea of ecotypes from earlier. Pods that are closely related and often meet tend to share parts of the same set of calls. A group of pods that share these vocal traditions is called a clan. So while ecotypes tell orca groups apart by how they live, clans tell them apart by how they sound. For skilled researchers, just listening to an underwater recording is often enough to know exactly which clan an orca belongs to. In this way, a dialect works like an ID card of sound, letting orcas recognize others from their own group without ever seeing them. Maybe the strongest proof that orca sounds are more than just simple signals that they are carefully controlled comes from a different kind of study comparing how different orca groups use sound while hunting. Resident orcas, which only hunt fish, make pulsed calls often while hunting. Since fish like Chinook salmon can barely hear sounds in that pitch range, the orcas' conversations don't give away where they are. Transient orcas, which hunt seals and sea lions, face a very different problem. Sea mammals have extremely sharp hearing underwater, so even a little noise could warn their prey before the attack even starts. Studies by researcher Dickey, spelled Faladica in the original, in Alaska, proved exactly that transient orcas stay almost completely silent while hunting, only making sounds after they've caught their prey or when the pod is resting safely. In other words, orcas don't just follow one fixed instinct for making sound. They actually change how they use sound based on what their prey can hear, a level of flexible behavior that goes far beyond a simple built-in response. But using sound to talk to other pod members is one thing. Using those same sounds to see through the dark ocean and find prey hundreds of meters away is something else entirely. If whistles and pulsed calls let orcas talk to each other, another kind of sound gives them something even more amazing: the ability to move around and sense the world using echolocation. Orcas make fast series of clicks called click trains. These are focused by a fatty organ in their forehead called the melon. These high-pitched sound waves travel forward in a narrow beam. When they hit something, a fish, a chunk of ice, or the ocean floor, they bounce back. The returning echoes travel through a fat-filled channel in the lower jaw, carrying the vibrations straight to the inner ear. By studying the timing and strength of these echoes, an orca can tell how far away something is, how big it is, and what shape it is from up to 150 meters away, even in total darkness or murky water. What's really amazing is that echolocation does much more than just find one piece of prey at a time. As the whale swims, its steady clicking builds a 3D map of the ocean floor below its shapes, deep trenches, and rocky areas where prey tends to gather. But finding prey is only the first step. Since orcas can grow to 9 meters long and weigh several tons, they can't just charge at a seal on an ice chunk or a group of fish. Different orca groups have developed special hunting methods to solve different problems. In Antarctic waters, orcas hunt seals resting on floating ice using a method called wave washing. A group of orcas, usually 3 to 7 of them, swim side by side in a tight group, speeding toward the ice, then diving together and rolling their bodies at the same time. This matched movement pushes a big wave forward. When the wave hits the ice, it cracks the weak edges and rocks the ice chunk, knocking the seal into the water. A wave made by just one orca usually isn't strong enough to work, but when several orcas move perfectly together, their waves combine into one powerful push. Sometimes the whole hunt takes just a few minutes. Other times, the orcas repeat this move again and again for hours before finally knocking their prey loose. Along some coastlines, most famously in Patagonia, Argentina, orcas use a completely different method called intentional stranding. During the sea lion breeding season, young, inexperienced pups gather in shallow water near the shore. The orcas time their approach with an incoming wave, launching themselves onto the beach to grab their prey, then rely on the next wave to carry them safely back into deep water. Getting the timing or wave strength wrong can be deadly. That's why intentional stranding requires very precise timing. The incoming wave has to be big enough to carry the orca onto the beach, and another wave has to come soon after to carry it back to sea. A third hunting method is used off the coast of Norway, where orcas hunt huge schools of migrating herring. Instead of wasting energy chasing fish one at a time, they use a team method called bait ball formation. Working together, the whales circle the school, herding thousands of fish into a tight, packed ball. They blow curtains of bubbles and make scary sounds to squeeze the school together. Once the fish are packed tightly near the surface, an orca gives a powerful tail slap, creating a pressure wave that stuns dozens of fish at once. This method doesn't depend on how hard one tail slap is, it depends on the group working together perfectly to surround, squeeze, and hold the fish ball until just the right moment to attack. These three hunting methods show a clear pattern. Orcas don't rely on one fixed hunting method. Instead, they keep adjusting their behavior to match their surroundings and their prey. But orcas don't always rely only on their own senses to find prey. In the northeastern Pacific, researchers have found an amazing kind of teamwork between resident orcas and Pacific white-sided dolphins. Using drone videos, scientists have seen the two kinds of animals traveling and diving together again and again, with the orcas closely following the dolphins into deeper water. Researchers think the orcas may be using the dolphins' excellent echolocation skills to find large Chinook salmon prey that dolphins can detect but can't easily tear apart or swallow because it's too big. Once the orcas catch and tear apart the salmon, the dolphins move in to eat the leftover pieces. This seems to help both animals. The orcas save time and energy by using the dolphins' senses, while the dolphins get access to a big food source and extra safety by staying near one of the ocean's most powerful hunters. It's important to note that these observations are still early. Since only a few of these events have been recorded, more research is needed before scientists can say whether this is a regular pattern of behavior. Looking back at this part of the story, a clear picture forms. An echolocation system advanced enough to build 3D maps of the ocean floor, 3 hunting methods perfectly matched to different environments, and even the ability to borrow another animal's senses for mutual benefit. All of these abilities come from the same amazing brain, which naturally leads to an interesting question. If this incredible ability to plan, adapt, and work together evolved for hunting seals, sea lions, and fish, what happens when it's aimed at humans instead? At the end of the last part, we asked a simple question. What happens when an orca's amazing ability to plan and work together is aimed at humans? To answer that, we first need to understand the organ behind those choices, the orca's brain. In the early 2000s, brain scientist Lori Marino and her team at Emory University used MRI scans to study the brains of whales and dolphins, including orcas. What they found was surprising. Along with the limbic system, the network in all mammals that handles emotions, orcas have a nearby area called the paralimbic lobe. This structure has no known match in the human brain or in any land animal studied so far. Marino and her team suggested that this special area might be involved in more advanced emotional and social thinking, but it's important to separate finding a structure from understanding what it actually does. While the paralimbic area clearly exists, exactly how it works is still an open scientific question. Another striking feature of the orca brain is that it has an unusually high number of spindle neurons, also called von Economo neurons. In humans and other great apes, these neurons are found mostly in brain areas linked to quick decision-making in tricky social situations, and they've been connected to abilities like empathy and social awareness. Orcas have a huge number of these neurons. Still, we need to keep the line clear between evidence and interpretation. A high number of spindle neurons doesn't automatically prove that orcas feel empathy the same way humans do. That idea is based on similarities in brain structure, not direct proof of how the brain works. It's a reasonable guess, but still an indirect one. So the next question is, do the behaviors we see in the wild actually show this kind of advanced social thinking? One example from the waters of South Africa gives part of the answer. Researchers found a young male orca that was missing both its back fin and its right side fin, a serious disability that would have made hunting on its own very hard. Despite this, the whale survived and kept growing within its pod. Observers repeatedly saw other pod members sharing food with the disabled orca and staying close to it while traveling instead of leaving it behind. From a behavior standpoint, here's what we can say for sure. The group kept staying close to an orca that contributed little or nothing to group hunts, and repeatedly shared food with it. But calling this compassion would go further than what the observations alone can prove. This behavior might serve several different evolutionary purposes, and researchers are careful about giving it human-like emotional meaning. Another behavior that's just as hard to explain is that some mother orcas carry the bodies of their dead calves for days, or in some recorded cases, even weeks. This is very costly in terms of energy. The mother has to keep pushing or holding up the calf's body at the surface, which slows her down and directly hurts her ability to hunt and feed herself, yet she keeps doing it. Right now, scientists are split between two main ideas. One says the mother is showing ongoing caregiving behavior, still trying to revive or wake her calf. The other says this behavior is a response to loss, similar to the long grieving reactions seen in elephants and some primates after a baby dies. Both ideas are still just guesses. What science can confirm is that the behavior is real, lasts a long time, and costs a lot of energy. What the mother orca is actually feeling is still beyond what current science can prove. The newest and maybe clearest example of complex behavior comes from a study published in 2025 about the southern resident orca group in the northeastern Pacific. Researchers saw orcas deliberately bite off pieces of kelp, then hold the kelp between their own bodies and another orca's body, rubbing it back and forth together. This behavior has been named allokelping. From a science standpoint, this discovery matters for two reasons. First, orcas have no arms or hands to grab things. Deliberately shaping a piece of kelp before using it this way meets the accepted rules for tool making and tool use. Second, it's the first recorded case of tool making in a non-primate animal that has no grasping limbs. Researchers think this behavior might help with skin care while also strengthening the social bond between the two orcas. Still, this is a fairly new discovery based on a small number of observations. More data is needed before scientists can know how common this behavior is and fully understand what it means. Right now, what science can't yet prove is what an orca actually feels inside while doing these behaviors. The difference between what can be observed and what can only be guessed at is worth remembering as we move into the next part, because the next question isn't about how orcas act toward seals or even toward each other. It's about how they choose to act when the animal in front of them is us. Even though they have all the physical tools needed to take down some of the biggest animals in the ocean, wild orcas have never treated humans as prey. Instead, history has recorded a number of unusual meetings that go far beyond normal hunting behavior. Between 2004 and 2024, researchers gathered and confirmed 34 separate cases where wild orcas deliberately approached divers or paddleboarders. The orcas offered people 18 different kinds of objects, including different prey animals as well as things that weren't food at all. What made these encounters especially interesting was what happened next. The orcas rarely swam away right after dropping the object. Instead, they often stayed nearby, watching how the person reacted. In some cases, if the person didn't respond, the whale picked the object back up and tried again, as if waiting for some kind of answer. Here it's important to separate behavior from motivation. The behavior itself, bringing an object, dropping it, staying nearby, and watching the person's reaction, is clearly recorded on video and in eyewitness reports. But why the orcas do this is still an open question. The research team suggested two main ideas. The first is interspecies altruism behavior that helps another species without giving any immediate benefit to the orca doing it. The second is curiosity, the idea that orcas might be using a familiar behavior from within their own species, sharing food on an unfamiliar animal just to see how it reacts. Both ideas are scientific guesses meant to explain the behavior. Neither should be taken as proof that orcas understand humans in any specific way. If prey sharing is a fairly new discovery based on limited observations, the relationship between orcas and humans in Twofold Bay in southeastern Australia is one of the best documented examples of two different species working together in history. From around 1840 until the 1930s, almost 100 years, a group of orcas living in the bay built a surprisingly steady partnership with commercial whale hunters based in the town of Eden. During the yearly whale migration, the orcas would find large whales out at sea, then swim all the way back to shore to let the whalers know, who were waiting in lookout huts. They often did this by slapping their tails hard on the water. After warning the hunters, the orcas would go back to the whale and help slow it down or block its escape, making the hunt much easier. In return, once the whale had been processed, the whalers left the tongue and lips for the orcas. These fatty parts were very nutritious, but hard for the orcas to get off such a huge body without human help. As one person described it, they did the most amazing things. What they used to do was round up the whales for the Davidson family and others. Just like people in the country use sheepdogs to round up sheep, trying to herd the whales into the bay from out at sea, so the whalers could catch them. This unwritten agreement even had a name among the local whalers, the Law of the Tongue. This wasn't just a local legend. The partnership was recorded across many generations of whalers, with individual orcas being named and recognized for decades. The most famous of them was an orca known as Old Tom. Taken together, these two stories, the recent sightings of prey sharing with strangers at sea and the century-long partnership between orcas and whalers, suggest something amazing. An orca's interactions with other species aren't always driven only by the need for food. In many cases, they seem willing to spend time and effort on relationships where the benefits aren't obvious or immediate. And that naturally leads to a hard question. If orcas have both the physical power and the mental ability to become dangerous hunters of humans, why have they almost never chosen to do so throughout recorded history? What exactly guides that choice? There's one important limit we need to admit. Science still has no objective way to directly measure the inner feelings or emotions of any animal. Some of the discoveries we've talked about, like allokelping and prey sharing with humans, are based on a fairly small number of observations. Because of this, researchers will need a lot more data before they can say whether these behaviors are common patterns across orca groups everywhere. In the same way, scientists generally avoid saying that orcas are the smartest animal on Earth. Comparing intelligence between species from orcas and chimpanzees to bottlenose dolphins, elephants, and crows is an enormous scientific challenge, mostly because there's still no single accepted way to measure intelligence that works equally for every animal. Still, even with these limits, one conclusion stays clear through everything we've explored. An orca's intelligence can't be reduced to just one ability. It comes from a mix of things: a social structure stable enough to hold on to knowledge across generations, a communication system that adjusts to changing situations, problem-solving methods matched to different environments and prey, and a brain that science is still only beginning to understand. What about you? Do you think orcas deserve to be called the most intelligent animal on Earth? Or is there another animal you think could make just as strong a case? Let us know your thoughts in the comments below. And that question brings us back to the puzzle we raised earlier in this video. Orcas have every physical and mental ability needed to become a serious danger to humans, but they have almost never chosen to use those abilities against us. So why would one of nature's top predators, fully able to hunt humans, keep choosing not to? That question has already been explored in depth in another video, and the real answer might be far more surprising than you expect. Thank you for joining us on today's journey of discovery. See you in the next video.